Hi guys, hopefully you've watched the intro to geometric progression video. If not, please go and watch that first. This will make a lot more sense. I'm just going to go through how to do all the questions in the pack now. Okay, see if you can listen to one or two and then pause the video and have a go at them yourself. Okay, it's only limited benefit to just watching me do maths questions. Right, number one, the first term of a geometric progression is 5 and the common ratio is 2. Write down the first 4 terms of the progression. Now, whether it be an ordinary arithmetic progression or quadratic or geometric in this case, if I'm asked to write down however many terms, I like to write down those term numbers, the n numbers in other words. So it tells me that the first one is 5, common ratio is 2, so I'm timesing by 2 as we go along here, so that one will be 10. Third term will be 20, and the fourth term will be 40. And the 10th term of the progression, this is not too bad to keep on just multiplying by 2, so I'd probably do it that way to get to the 10th term. And to do that, I'd have to multiply by 2 6 more times, so the 5th term would be 80, the 6th term would be 160, 7th term would be 320, the 8th term would be 640, the 9th term would be 1280, and the 10th term would be 2560. Okay, number 2. We could have also used the nth term rule that we learned about in the video, previous video for that as well. So just remember the nth term of a geometric progression is a r to the power of n minus 1. So if I want the 10th term for this sequence, this would be 5 times a constant ratio of 2 to the power of 9, because I'm after the 10th term, so I do 10 minus 1, gives me my power. Okay, now just using a calculator here, 5 times 2 to the power of 9, you see that gives us the same answer. Okay, number 2, first term is 2 and the common ratio is 4, first 4 terms. So times them by 4, that would give us 8, times that by 4, that would give us 32, times that by 4, give us 128. The 7th term of the progression, there's only a few more to go, whoops, so I'd probably just keep going personally. So times that by 4, $512, times that by 4, 2048, times that by 4, 8,192. And I've just hit upon another thing you can do for these questions to generate the sequences. If you want a quick way to do it, if you type in the first term, so 2 in this case, and times by the common ratio, 4. In fact, sorry, if you just type in 2 and press equals, your calculator will remember that that is the current answer, the previous answer, if you like. So if I got rid of that, and then just press this answer button down here, pressed equals, 2 would come back. Now if I press times 4, that takes the previous answer and multiplies it by 4. So press equals and it will give me 8. Now what will happen now is that the calculator has now assigned this 8 to the answer key. So the answer is now 8. If I press equals again, it will do 8 times 4. So I can just keep pressing equals and it will keep multiplying the previous answer by 4. Very handy for this topic. Okay. If we were to use the nth term rule to do that, calculation would have been 2 times 4 to the power of 6, which should also give us that. Okay, the first and third terms are 7 and 63. What is the common ratio? So the quickest way would probably be just to guess something. Now it's not going to be 2, it is going to be 3. That would give us 21. Times that by 3, it would give us 63. So the first 4 terms, just need the 4th one now. If I times that by 3, that's going to give me 189. And the 15th term, no way I would keep doing this unless, I just kept pressing equals on my calculator, I suppose. I'd probably use the nth term for this one, so that's going to be the first term times the common ratio to the power of 15 minus 1, so 14. That'll be the quickest way to do it. Oh, my calculator's gone. Where's it gone? Okay, so quite a big number this one. Whoops. 3348. Okay. Number 4, the 5th term is 11,664. And the 6th term is 69,984. What is the first term? Well, because we've got consecutive terms here, to work out what this common ratio is, what we've times by, we could just divide the 6th term by the 5th term. So if we do that, that would give us R. Okay, divide by that, we get 6. So we can now just keep dividing by 6 to work backwards. So that one's 1944. 324 is the third term, 54 is the second, and that means 9 must have been the first. Number 5, first 4 terms are there. What is the common ratio? Now this sequence is going down. Now that doesn't mean we are dividing. Well, we are dividing, but we can also still state it as a multiplication. So, and to do that, we would just take 2 consecutive terms, exactly like we did in the previous question. We just divide the second one by the first one. Okay, so 375 divided by 1,875, and it will give us a fraction, because timesing by a fraction is the same as dividing by that denominator. So timesing by a fifth is the same as dividing by 5. So the common ratio R is 1/5. The 8th term, you can just at this stage just think of dividing by 5 if you like, just keep going. So there's the 3rd, 4th, 5th term, if we divide by 5 that would be 3. 6th term, if we divide by 5 that would be 3/5. 7th term, dividing by 5 would give us 3/25. And the 8th term, divided by 5 would give us 3/125. Number 6, the 3rd term of geometric progression is 192. The 4th term is 48. What is the first term? So this is a very similar question to one of the ones above. To work out this number, we're going to do 48 divided by 192. So a quarter. In other words, we are dividing by 4. So if we want to go backwards, we can times by 4. So the second term is 768. And the first term is 3072. And final question on that page, the 3rd term is 12 and the 4th term is 24. So hopefully you can see there that the common ratio is 2. Work out the difference between the 1st and the 5th terms, so we've just got to find out what they are. Times that by 2 would give us 48. We divide by 2 to work out these other ones. Second term would be 6, first term would be 3. and the difference between 48 and 3 is 45. Okay, so this isn't a really long video. I'll do the next page on the next video.